In the next few objectives, objectives 14 through 22, we'll turn to a study of lipids, which you probably know of as fats. But as we'll see, there's a lot of other different kinds of lipid molecules that aren't exactly fats. These are fats and fat-like compounds, related compounds. Lipids, like carbohydrates, have carbon, hydrogen, and oxygen, but there are different proportions. As we begin to reduce the amount of oxygen in these molecules, then we make them less and less likely to engage in interactions with water. So for that reason, we call them hydrophobic. Hydro meaning water, phobic meaning afraid of. So they tend to repel water, and for that reason we call them hydrophobic. Another related term is nonpolar. These two things are related to one another. A hydrophobic molecule tends to be nonpolar, and a nonpolar molecule tends to be hydrophobic. These are very important in the body for building the membranes that surround each one of the cells, as we'll see in Module 4, but for right now we'll just make passing mention of that fact. And you can see on this table the many different varieties of lipids that are found in the body, all of which we'll study now. Now I mentioned the terms polar and nonpolar. Polar molecules are charged, and so they have an excess of positive charges or an excess of negative charges. That is, they're cations or anions. They like being around water, and so we call them hydrophilic. Hydro is water, philic is loving. So these are water-loving molecules. Nonpolar molecules are not charged. They don't form ions. They don't have an excess of positive or negative charges. They are neither cations nor anions, but rather uncharged molecules. And for that reason, they hate being around water. We call them hydrophobic. We can see here that the same molecule can have hydrophilic regions, and in this lipid molecule there's a hydrophilic region at the top we call a polar head, and a nonpolar or hydrophobic region we see at the bottom we call nonpolar tails. So stepping back to the bigger picture, what are lipids? Lipids are hydrophobic or water-insoluble substances. They fit into one of four categories, either simple lipids, fats, oils, and waxes, or compound lipids, some of which we've been looking at already, the phospholipids, the sphingolipids, and the glycolipids. Steroids are an example of lipid molecules, and when we look at steroids, we'll include them in this category. And then there's sort of miscellaneous lipids, which are combinations of lipids and proteins called lipoproteins. Also, the fat-soluble vitamins fit into this miscellaneous category, and we'll be looking at examples of those as well. So lipids come in many different forms. There's the fatty acids, which we mentioned briefly when we were talking about the dehydration synthesis. When we combine fatty acids with a glycerol backbone, which has 3 carbons, and so it takes 3 of these fatty acids on it, then we can form triglycerides. So they're called triglycerides because they have 3 fatty acid tails. And so we can see the 3 hydrophobic, nonpolar fatty acid tails on this triglyceride molecule. We can have phospholipids. So these have a phosphate-containing group on their polar end, and they still have 2 nonpolar tails. We can have steroids, eicosanoids, and then we can have other lipids like the fat-soluble vitamins and the lipoproteins. Remember that the lipoproteins are fairly large structures, and these represent the way that lipid molecules are carried in the blood. Since lipid molecules are insoluble in water, they'll come out of water and form an emulsion or a colloid, and that won't help them get into the cells. Then we need to carry them as lipoproteins. So as the name tells us, this is a collaboration of proteins with lipids so that we can move lipids around in the blood and get them inside of cells. The exact way that these get into cells we'll look at in Module 4. The first of these is fatty acids. We saw fatty acids earlier. They have a carboxylic acid end. And then the remainder of the molecule is a long chain of simply carbon and hydrogen atoms. Remember that when carbon and hydrogen atoms go together without oxygen being around, that these don't have very much of a charge, and so they don't love water very much. So these carbon and hydrogen structures are very hydrophobic, don't like water very much at all. There's a couple of different ways that we can have these fatty acid chains. We can have simply CH2, 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 CH2 repeated over and over again. That's what we see in this top molecule. Or we can occasionally break up that tedium with an occasional double bond. When that happens, we call these unsaturated. So each one of these double bonds that occurs is called unsaturated. And when we have these double bonds in a lipid molecule, that puts a little kink in the molecule, which is going to have some profound effects on the properties of these fatty acids once they're added together in a triglyceride or in a phospholipid molecule, for example. So when we say saturated, what we're talking about is that each carbon atom is filled with hydrogens. In other words, saturated means no double bonds, no kinks in this molecule like we see at the top. Unsaturated molecules are called that because they don't have all the hydrogens that they could possibly take. We could think of them as missing hydrogens. That's because the double bond excludes hydrogen at the point where it occurs. We see a double bond here. If there's one double bond in this lipid tail of a fatty acid molecule, then we call these monounsaturated fatty acids. If there are multiple double bonds in this fatty acid tail, multiple instances of this kind of double bond, which is going to put many kinks in the fatty acid tail, and that's going to be called polyunsaturated.